Let's start with company update. Any company update?
Yeah, so we had a good revenue year this year. I'm looking at our Shopify sales. So our Shopify sales are up 22%, but we made 1.5 million last year, and we made 1.83 million this year. That's some tiny box sales. And then in addition, we made $400,000 from AMD. So yeah, our revenue is up almost 50%.
Does that include the pros or
Uh,
just the things
e-
from site?
that should be everything. Not anything we did with comma, but that should be every box that we sold. Because we
Great.
put all of that through Shopify basically. Just to track it and make sure we fulfill it and all that stuff.
And also the RTX 6000 bucks seem to be selling pretty good.
Yeah, the RTX 6000 box is selling. I mean, like when you look at the revenue from last year, it was heavily in August when we launched the tiny box and finally got it shipped. We had a pretty bad first quarter of the year this year, but I'll just post the Shopify thing.
Mhm.
Um,
Okay.
I'm pretty happy with that. Uploading the image now.
Great. Okay. Anything else?
I think that's basically it.
Okay. Oh, I see. What happened to August last year? Oh, that's when we launched? I don't remember.
Yeah, August last year was when we actually shipped all the tiny boxes. I mean, we didn't take the money until we actually shipped them. Like launched them in April, but it took some amount of time. But yeah, no, I think like we didn't have anything for the first half of the year. Then when the green boxes came in stock, May, July was our top month, but it's been pretty stable. We've been making like 300K a month since July. It's pretty good.
No one buys the Red V2 box.
Oh, we sold several Red V2 boxes.
Okay.
Red V2s are selling. Yeah, Red V2s are selling. I think we got our first two of them shipped. No, it's a bigger hit than the red box. I mean, I think the price just appeals to people.
Mhm.
Had to sadly do a little bit of power limiting on that box, but if the GPUs come overclocked. So it works at their stock power, but it doesn't work at their overclocked power. It'll brown out, start getting GPUs falling off the bus. So we capped them to stock power. Everything's good. The Blackwell box is super stable. It's interesting. The fans on that card are different from like the normal GPU fans. We had to lay the cards out differently in the box. We put the three like the full vertical height of the tiny box. Then we put the fourth card all the way on the other side. Still the hottest card, but they all stay below 80 now, so pretty happy with that. Yeah, and I think we might have got our first of those shipped. I'm not sure. I will start. Yeah.
I know that a Red V2 shipped. Not sure if any Blackwell shipped yet.
This week. And Chris, are you in the office?
I am, yeah.
Well, welcome. Welcome to your first day.
Yeah, thanks.
I think you know what you're working on. Let me know if you have any questions or need anything. But yeah, no, I told Julie to help you with any onboarding stuff you need or.
Cool.
Great.
Yeah.
Okay, let's move on to. I did some update to the training loop. starting to test the gradient accumulation. Memory looks correct, but my llama run was killed, and I was testing BERT with similar changes, and I see weird loss. So, but the memory looks fine. Gradient accumulation starting from 2 uses and memory. To the gradient
Yeah.
accumulate beautiful MNIST, except I didn't do the single big gradient thing.
You're concerned at all about the JIT causing issues? If you run with debug equals 1 and JIT equals 0, you can see the schedule task and make sure that it's scheduling the same thing before the JIT actually kicks in. Like the schedule task puts a hash out of the schedule, and if for some reason those schedules are changing, there's no way that this is going to work. JIT might not still work, even if the schedules don't change, but if the schedules do change, the JIT definitely won't work. So if you're looking for ways to debug that, but yeah, hopefully the debug equals 1 output is pretty intuitive. Like it shows you your schedule and then it shows you the hash of that schedule, and you can see like each step.
Yeah. So anyway, I think if the BERT run, I think BERT run is a good test for correctness, and I'll find time to run the. I think if we have gradient accumulation, then depends on if I can test with flash attention that we can discuss later. We can have a 8B run training.
Right.
Yeah, I will look into the similar parameters for how they train the AB and add some defaults. For now, the script was using a default from 4.5B, so the hyperparameters are off. Yeah.
Yeah, I mean, it'd be nice to get a qualifying run if it's not too hard for 8B as well.
Yeah, I mean, aside from it takes some time, it should be fine.
I mean, it should be pretty fast though, right? Like how fast are other people getting it? I guess we're only using one GPU now, but
I don't know if they have the runs with one machine. I can look later. But yeah, also briefly consider if we want to merge Fuse Optim and stuff like that. It's a little bit annoying if you shard things slightly differently, because then I don't know if you want to group your gradients or parameters by how you shard it and try to concatenate a big one or something like that.
the idea might just be to like do it how I did it in gradient accumulate MNIST, re-implement the optimizer in our trainer. Like then to try to like we can update the optimizer later once we know what it should look like.
Yeah, so I think at some point we want a functional update that take into all the parameters you need and basically just assign to a new set of parameters, and we can call that function in the current stateful one in the class. It also has similar functional API like that.
Yeah.
But another thing
checking.
Another thing you did is the one big gradient, and you just store layer location and try to, instead of having each parameters holding its gradient, have like one big gradient for everything and update through that. That is a bit annoying if you shard your things differently on multi-GPU.
Yeah, I mean, we could actually even go as far as do the sharding manually and just create sensors for the gradient on each CPU and then decide which to put in which place.
Yeah, that I briefly consider. We'll probably think more about that when we are in the model parallel for the big llama.
Yeah. So I have the ML perf. Llama 8B trains on MI350X in 2 hours. PyTorch.
One
Yeah.
MI350?
8 GPUs. Oh, 8 GPUs, so one machine.
Oh, great.
So hopefully we have we can get a similar time to that pretty soon.
Great. Okay. Let's move on to the important part of this. Let's flash attention.
Yeah, so I merged Flash Engine and Tensor.py last week. I also merged a bunch of prereqs for backwards pass. So backwards pass should land this week. I think probably Wednesday. Before Wednesday, because I'm flying out Thursday. So I'd like to get it in before Wednesday, so we can start runs.
Great.
Should be good.
You should be able to test with Bird. I think Bird is. We know how Bird behaves, and it also trans faster. And you can run that on smaller machines. Or it won't work. Does it only work with
It won't work.
MI350?
It only works on MI350.
It should work with at least MI300 as well.
Yeah.
Do that. Yeah. I think because then we have 4 machines, we can try it on all 4 machines. I think that's pretty good. Like kick off some BERT runs on the 300s.
It's slightly annoying because we don't have disk. We don't have all the data on all the machines. I was trying very hard to find a machine to train my BERT.
Can we not copy it? Do we not have the physical disks? Or I know the 300 machines have big RAID arrays. We can copy them to.
Because we also want the big llama dataset and a small llama dataset and then a wiki dataset.
So we have a bunch of those hard drives now. We might want to try to get some PCIe 5 cards in the MI325X machines. Well, it's hard if you want to do that before you go, if we're going to have data problems.
I remember we tried this, and then we could never get the cards to actually show up.
Oh yeah, we tried a few things. So we tried those enclosures, and they didn't work. Not sure if the problem was the enclosure or the problem was the
Yeah, so I've also tried a
PCIe.
RAID card by swapping out one of the network cards on the front of the machine.
Did that work or no?
No.
Okay, then I think we kind of get what we get. I mean, we can also, if the data can be fast enough, we can hit over the network too. Do you want to do like
Yeah,
NFS
that's also
or something?
doable. There's not that much data. It's only like tokens.
Yeah, I mean, if we can fit it, we just need to make sure that all these machines can kick off trainers, like all 4 of the big AMD machines.
Yeah, they can fit all the data on the machine.
Oh, great. Yeah, then let's just do that. Make sure it's distributed, like rsync it across the machines.
Yeah.
So yeah,
If we
no,
wanna
fast attention, doing a successful. Good.
If we want to fit more data, I can move the OS to. There's another NVMe drive in the machine that we didn't put the OS on because for some reason it wasn't showing up before, but I got it to show up by doing something. I forgot exactly what I did when I was testing this. But I can move the OS there and we can get another 4 terabytes.
Cool. The most important thing is that the machines do not break. I don't want to have broken machines. But yeah, no, whatever it takes, basically, we should be able to kick off BERT trainers, Llama 8B trainers, and Llama 405B trainers without a problem. Wait, 405B, where are we going to store these weights? Yeah, I think a great goal for on Thursday would be to have a BERT training run succeed with class attention forward and backward, and then have all the machines be able to replicate it.
Sounds good. Anything else?
That's all.
Okay, let's move on to this.
I added PMCs to the UI tab. So if you run with physicals too, you'll see it. It's in the table. But the problem with these counters is that you don't really know why they are happening. So I am next is I'm going to build a memory access visualizer to exactly show which threads access which parts of the buffer. And that way you can see if it's coalesced and stuff like that. I think Hip Kittens has a nice visualizer for this. They didn't open source it, which is sad, but we have a reference picture of how it supposedly looks like.
We could probably message them on GPU mode, and I'm sure they'd open source it if it's in any sort of state. It's probably in a really bad state. But I'm thinking about how to like close a loop for you on Viz, and I think what you should work on is making the gem fast. Work on making the gem fast on the MI350s. We need that for Llama, and then you should work like close the loop between tooling and the gem, right? Like here's the gem, make it faster. Oh, this would help with this tooling, improve the tooling, so on and so forth. Keep that like loop going. That's
Sounds good. AMD of Matmul.
one petaflop by the end of the year. Well, not just AMD UART Matmul, but also the one for the MI350. AMD UART Matmul is just for the RDNA retards. But yeah, no, I think it would be great if you could get one petaflop by the end of the year on the MI350. And we can actually use that in the Llama. And then if we have flash attention, if we have petaflop Matmuls, we're looking pretty good.
Anything else for Viz?
Chenyu, I know you asked about the rewrite index feature. I added in the branch. Is it useful to merge more?
Oh, yes. Oh, I don't quite remember. I think it was useful. Let's discuss this later. I don't quite remember the details.
Yeah, that's it.
But I want something like that just because there are rules that is very hard to find where it is used, especially if you're looking at a very giant rewrite. I think this is similar to the track rewrite status, maybe slightly different, but the idea is you want to see where some rules is used before you can decide if you want to move it or delete it. Okay. Next, for the drivers.
Yeah, so for the MI350 bug, so actually I fixed a lot of bugs in our runtime, but this one's like in the Llama loop still happening. And actually it's pretty strange because like what you see in the mask, it's almost the same address, like somewhere at the 48-bit address at the top of the at the top of the memory address space, and it's actually from the instruction cache. So that's really strange. I mean, to my guess, maybe we have some stack corruption, but I'm not sure we use stacks at all because we don't do any function calls, I believe, and also that's not really reproducible. So I think it happens in different function calls every time. So
how's the AM driver going for 50?
yeah, I'm working on it. So basically, yeah, it's fine. So yeah, I need to fix resets because they're also different to my 300. That's the only, and yeah. So
Yeah,
that's the
no,
only
so
part which missing.
the issues, almost all the issues in RDNA 3 were caused by the thing that was trying to like the CSWR, like the context wave state restore stuff. I wonder if it's possible that this crash is coming from something like that. Like, do we have any of that sort of stuff enabled?
I believe we do, but there is no mess. So
Yeah, but even though there's no mess, anything it would not surprise me if that's the problem. Like some old context is getting restored from something that's no longer in the instructions. The PC is going to some weird address.
yeah, yeah, I can try to disable that.
But I think it would be better maybe just to go with the AM driver, and then we just know exactly what's in there and what's not.
Yeah.
I don't like the idea of it being our own driver. I would be so happy if the AM driver can lower the power draw of these things. It's costing us like $3,000 a month to keep these machines idle. And yeah, I looked into it a bit. It's just it can't lower the M clock, so the M clock is always running at 2 gigahertz.
Yeah, I mean, if it's possible in hardware, so yeah, we definitely can do this in AM.
Right. Yeah, save money.
Another related thing is there are some like overflows in index or the way we store numbers that can happen. And we are seeing more of these with the bigger machine because if you have like 8B and store everything in one giant tensor, then that overflows.
Interesting. I thought our indexing stuff would deal with all of that. Bugs that
Yeah, so our indexing stuff deal with that, and hopefully the generated code is correct, but there are some places that use the when we pack the numbers with the corresponding type, maybe the number is like set to be like int32 or something like that. The Python pack and pack stuff. So I think the example is if you just create a one giant, I don't know, like 10 big tensor, and that would fail.
Yeah, it'd be great. Let's get some testing for that. We definitely don't want those kind of crashes. And how is the HVAC decoder coming?
I mean, it's cheated, but it's not very fast because the get item still takes a lot of time inside cheat. Like it's cheatable, like the function is cheatable, but it still produces some time in schedule.
Take a look at that. Take a look and see. I still sell.
Sounds good. Anything else for drivers?
No.
Okay. Move on to Mesa.
Yeah. I'm not totally sure what's going on here. I mean, I found some bugs, but at this point, I'm starting to think that there might be a bug in Mesa pertaining to register allocation. I'm not totally sure what's going on, but it seems to work without no locals set. So, to my understanding, the no locals optimization, like it's a strict subset of the stuff that Beam can discover. I don't know if that's correct, but I think
Is that correct?
I mean, the thing that allows you to do is to.
We have some
Sorry?
fractional stuff, and that's why no local is fast.
No locals. Okay, so no locals does two things. Local. So you can read two different. There's two different functions in OpenCL. One that reads the group work ID, and one that reads the global work ID. So the global work ID is the group times the number of locals plus the locals. So no locals is a function that will run with any size locals. A little bit of search in there that'll search over all the possible locals to see what's fast. The main advantage you get with this over the other path, Qualcomm allows for fractional globals. So Qualcomm, the locals do not have to divide the global size evenly. that makes things faster. But if it doesn't work, if no locals doesn't work, that's fine. It's not that much slower. We're talking about like 5-10% here.
Okay. Yeah. Anyway, I'll look at it a little bit longer, but at this point, like I feel like the bug here is actually something in Mesa because it's just like I fixed some stuff, but I've been looking at the outputted code and it just seems like it's clobbering. I'd have to double check. I want to try and find a minimal reproduction so I can look through the code and make sure I'm not confusing myself. But it really does look like it's clobbering its own indexes into the image load. Anyway, I don't know.
Yeah,
the Qualcomm code definitely it all works without image support, but that's that's not that's to be expected.
Yeah, we really shouldn't be spending time on Mesa bugs. I think the next project here is to get image removed from D-types and get the low-level image rewrites to work, be that with the Qualcomm backend or the Mesa backend. It doesn't really matter. The
Yeah, I
important thing
agree.
is to
So
get the image stuff.
yeah, then that makes sense. I think I kind of just want to merge this in the state that it's in, and maybe just say like no, the locals doesn't work, and then I can start working on the real interesting project, which is the trying to get images to work properly or without the image equals to.
Fine.
Merge the image equals to 1 vision model to the benchmark. I think now it's just 3x slower.
That's good. We need to make image equals 1 fast.
Yeah.
Yeah, also probably we'll want to test Levis beam to see if it's just we do 1 less upcast and it's slow, something like that. But anyway, making image equals to 1 fast would be great.
Yeah.
Okay. Anything else from you? Oh, can you briefly talk about the state of C-type bugs, like what to use, what not to use?
Yeah, I think everything is fine. I think I fixed everything that people complained about in the bug reports channel. But yeah, the bug is with or the most recent bug that I encountered is with C_bool. If you have any C_bool with a bit field, it's just totally broken. Like it just doesn't work at all. So but I there's a patch for that now. So like our structure implementation deals with that. So it shouldn't cause any issues. But if you encounter more bugs, let me know and I'll fix them.
I really like the project of just not using C-type structure and just replacing that with something else. C-type structure is slow, undocumented, and changes. Something that just manually manages the field. I'm very supportive of that project too.
Yeah, that's also something that I want to do. Yeah. Yeah, I don't know if that's as high priority right now, but yeah, definitely it'll be nice to do, and also probably get syntax highlighting working and just a better syntax in general for defining these structures.
Yeah, I mean, I think the priority should be determined by how annoying the bugs are. If the bugs aren't annoying you, then it can wait. If the bugs are annoying you, then be like, well, instead of pouring more effort into fixing these bugs, just rewrite it differently. But if the bugs,
yeah, I think if I encounter too many more bugs, I'll yeah.
Okay. Sounds good. Let's move on to other bounties. We can start with B1TG. I saw your training run. How are things going?
Hello?
Hello.
The MMU fault basically fixed by imaging. It can still happen, but with small probability. I have few success ATPU runs. Now the problem is it can't coverage.
And do you have
The coverage can now be 0.7, but can and reach the 0.72. So I was planning to adjust the FP layer a bit and also try the block scale.
I remember
Mostly
last
caused
week.
by the
Last week you
What?
talk about. Last week you talk about you want to use FPA or not using FPA in the backboard, so you need to use custom. Is that what you are doing now? And also your background.
it didn't influence the coverage a lot. I have a few flags to control the backward behavior. So
Okay. I think it'll be useful if we just share some of your experimentation rounds in the bird channel or something like that. Because I also don't know anything about the channel. So.
okay, I will put something this week.
Cool.
And also, when I wait configs, I add the FP8 support for the MI300. The FP8 implement is different MI300 and the MI350. Do we want that?
I don't know in what way they are different. It's just because the first told you the different things like before, and it's just like really different things we need to discuss, like what's the correct pattern for that. I know for now we are using like E-type close A or flat, but it might be like everyone use slightly different. Using FBA.
So I guess basically we want to match the behavior with touch, pure touch.
I think generally for torch is unless we have a very good reason not to match here, we should match their behavior. There are a few cases that we clearly know torch behaves weirdly and they document this in their code for some like legacy issues. Other than that, I think it's a good starting point to have the behavior match torch.
Okay, I will put a PR later.
Yeah, just also feel free to open an issue saying this is a current behavior, it doesn't match, and it should or it shouldn't. Adding some context helps here. Exciting. Yeah, I think if we can get FPA training, it also helps a lot with Llama. Okay. Anything else? Okay. Oh. I see Flata is here. You want to say something? Are you training model too?
Not yet. Just still working on the data loader. I'm trying to figure out how they're doing the seeding. I think that was my question from last time, but I'll dig into that how they do it because I think they generate I think what was it, the classifier free guidance to based on the random number generator, and they were using like the typical PyTorch data loader. So we just have to make sure that's consistent with the with my implementation for the Flux version. for Tinygrad.
Yeah, I don't have too much. I don't have like things to say about this. I think generally the idea is so our llama implementation. I know was parrots pretty much copy what the reference was doing. Maybe with the caveat that the reference also use a lot of weird flag. So who really knows like what is really being used? But the idea is with MLPerf, it's important to know if they have specific order for how you load the data. Do you reshuffle the data? Do you shuffle within batch? And if so, how much is your like shuffle window and things like that? I think as long as those are well understood from the reference, our real implementation, as long as they match that in spirit, we should be good.
Okay, sounds good.
Yeah, and I mean, assuming our model convergence is not dependent on the shuffle order, then even if we use the wrong one, it should be fairly straightforward to just use the correct one. Our training shouldn't depend on the order anyway. Okay. What else do we have for other monkeys?
So I've been working on not that. That's just in my clipboard. On a complete reimplementation of the USB chip firmware. It's amazing how good some of these agents have gotten. You have to really work hard to like keep them on track and prevent them from doing dumb stuff, and you have to like you got to really stay on top of them. But this is almost a complete reverse engineering of the firmware that's on the USB chip that we're using. So this is finally going to enable the speed for Comma to start using this chip. And yeah, no, I've been impressed by like you can read the register map in there is so much better than any other register map we've ever had for the chip, and it all actually does seem pretty correct. I've checked it with the stuff that I've manually reverse engineered. So this is the main thing that I've been working on. I'm going to finish it up this week. I'm also going to work on Python speed, and I'm going to work on improving schedule cast. So schedule cast can actually do a lot more than what it's currently doing. We're only schedule casting like one little part of the scheduling, but you could schedule cast all the way through. I'm also going to look into that HSEC thing and see why the bit's still slow. Think about how to schedule cast should get you 50% of the JIT behavior for absolute free. So in the whole project of making Tinygrad easier to use, that's I'll be working on that and working on the SP firmware.
Sounds good. Oh, is the Whisper thing ready for review? I feel that's
Finally?
been there forever. Whisper. Okay, I don't know. I also don't see the upgrade from the Winograd. Don't know what happened there.
I'm also going to merge this thing, bumping Onyx to 1.19. Unless there's any reason not to.
The reason might be why not do 1.20?
Oh, yeah, we should do 1.20 as well, but
Sure. If it looks
yeah,
good.
let's merge it. No, I probably should have tested it with the. Okay, well, I'll revert it if the comma stuff breaks.
Okay. I don't think any other funky. Anything else for this meeting?
What else we got on all there? Yeah, I don't really think there's much else. Again, I'll say overall, I'm very excited at how good these LLM agents have gotten at reverse engineering, and they're not quite there yet. But I can easily see a world in 2 or 3 years where I can hand it something like the AMD mech firmware and be like, re-implement this and see, and it will reverse engineer everything about the chip, even from nothing. Build you register maps, build you driver abstractions that perfectly match function for function, the real one, but are re-implemented in very readable C that probably is maybe even more readable than the original repository. So the era of companies being able to keep hardware secret, just releasing binary blobs for firmware, is coming to a close, and this is extremely exciting for all the stuff that we'll be able to make these AMD GPUs do, all the stuff we'll be able to make these chips do. I think that this is the pinnacle of what LLMs themselves can do, is just cut through all of this noise that's in these firmware things, and we can build things that look like Tinygrad that just are the true essence of the code without all of this abstraction nonsense. I posted that Twitter post about the USB, not the USB, the GPUs over the network. I think that's eventually where we want to go. I can see that actually happening in, yeah, like 2 years. I could totally see us selling a network attached NAG network, and like NAS, like network attached storage. This is NAG. This is network attached GPU. Just huge racks of just GPUs straight on network cards that are all driven from a single machine using Tinygrad with like an IPython notebook. But there's a lot more to do to get there. But I think that's kind of the long-term vision. And I saw someone, I should retweet that. I saw someone tweet basically like, maybe all these abstractions that the cloud providers have been pitching to us have just been kind of scams to get you locked into the cloud. And I think that's totally true. I think that from the perspective of what people really want, is the abstraction that they want is the abstraction at the model layer or at the tensor layer. They do not want the abstraction at the SIROV of the GPU. Like that whole abstraction stack is wrong. The right abstraction stack is tensor across. There should be no distinction between 1 GPU, 8 GPUs, 1,000 GPUs. It's all just the same problem at every level of the hierarchy. And yeah, that's the Tinygrad dream. Take all of that, every level of a hierarchy, use the same code. You can start to see this now between the difference between the big graph and the small graph getting smaller and smaller and smaller. I can almost see separating the small graph into pieces based on where you have barriers. Like barrier is the same thing as bufferize, not exactly, but like unify all of this and then schedule hierarchically at all the different layers. It's the same problem repeated at every scale.
Great. Okay, that concludes this meeting. Thanks, everyone. See you next week.
Thanks. Bye.